Hello guys, so in this video we are going to go through our Buggy motion lab. Okay, so our purpose is to investigate motion, and in doing so we're going to use this this Buggy, which we've got right here for you. It's nice red little Go Buggy where you turn it on and it just rolls forward. Okay, so by the end of this, the idea is that we're supposed to be able to accurately and precisely measure the position of the Buggy, and then generate and interpret 3 different graphs for the Buggy. The first one, position versus time, then velocity versus time, and acceleration versus time, okay? Our materials that are going to be required for the lab are motorized Buggy car, okay, which we've got right here, the meter stick, which we've got right for you right here. We've also got a stopwatch, which I'll be using a telephone, cellular device. And the last one is painter's tape, okay? And we've actually already marked off 0 meters, 1 meter. So we're going to be measuring our units using meters, okay? And then from there we can convert. But remember, whenever it comes to the precision, if we've got our floor marked in meters, right, then we can only be as accurate as 1 level more than meters, which would be decimeters, okay, which means 1/10 of a meter. All right, so for our procedure, we're going to first turn on the Buggy car, and to do so, we've got, there it is, there's a little switch on the side, on and off. Okay, so we can cut that for a second. Mark the starting point, which we've already done on the floor, and hold on, can you cut it for a sec?
Oops,
sorry. All right, and then as the timer reads, as we see the timer, I'm gonna go ahead and call out every time it gets to each of the intervals 5, 10, 15, and 20, and my helpers here are going to tape off on the ground wherever the front of the car ends up being at each of those time intervals, okay? So it says repeat steps 1 through 4 for a total of 3 trials, and that's what we're gonna do. Eventually, you guys will be calculating the average position using the data that we're going to collect here. Okay, so let's go ahead. We're gonna start here with trial number 1. We're gonna have the front wheels on the tape, and 3, 2, 1, go. I'll tell you when it gets to 5 meters. Might wanna keep it in line. There you go. Oh.
Fine.
I messed up. Okay, let's start over. Yeah.
It's an experiment.
You guys get to see physics in motion.
Yeah.
So it's all trial and error. Yeah. So holding the phone and pushing the cart and telling the time, it might be a little bit too much to me. Okay.
Or you could use the meter stick to keep it in line. That's
right.
also what we did.
Yeah, the meter stick's the persuasion stick. Okay.
Beat it into submission.
Yeah, beat it into the right path.
Tell the children.
All right, in 3, 2, 1, we'll go ahead and start. And 5 seconds there. 7, 8, 9, and 10 right there. Going for 15 now, hold on. And there. 17, 18, 19, 20, mark it. And that's done, okay? Each of the time intervals, hopefully I got all that on camera. And let's stop that. Okay, we'll go ahead and reset.
Or 7 meters here.
Can't pause it. I'd rather it be one long video.
Okay, cool.
You know what I mean?
Well, I don't know. So how do you want to record?
All right, guys. So let's go ahead and get our scribe to
Seems like
put
he's
her
not
paper
gonna
right
go.
here. No, we're good. I know exactly what to do. Put our paper right here. Yeah, that one. So we can show them what we're doing. All right. So yeah, just place that guy right there. Okay, so on trial 1, we're gonna fill in our data right here with me. Okay, so at 0 seconds, how far were we? Well, we should have been at 0, so let's go ahead and write in 0 meters on this first block. A lefty. And at 5 seconds, now we're going to make our accurate judgment, and we're just gonna have to pretty much do that for you. Well, we know that it's at least 2 meters, and from there, we're going to make our 1 level of uncertainty guesstimate. So it's a little bit past 2, maybe 2.1. So we're gonna write 2.1 meters on that second. Okay, 2.1 meters. At 10 seconds, we've got this guy right here. What do you think, Miss Horn? 3.7?
Definitely 7.5 or 7.
3.7? Sure, let's do 3.7. Okay. All right, excellent. Oh, not 7.5. We can't be that accurate. Remember, we're only one level of uncertainty past the meter. Excellent. 3.7 and 15 seconds looks like was this mark just before the 6. So we know it's at least 5, and then we make our judgment from there. I think we'll say another 5.7 or 5.8. No, let's say 5.8. Yeah.
5.8.
Yeah, 5.8. We'll write in the next one. Excellent. And then 20 seconds is this last one. So it went 7. Looks like it made it just past halfway. 5.6. I'm sorry, 7.6.
Yep, 7.6.
7.6 there. All right, now time for trial number 2. Here we go. Hope you guys are enjoying the weather, whatever it might be doing right now. Just kidding. All right, trial number 2 in 3, 2, 1, go. 2, 3, 4, and 5. Oops. 10 right there. Sorry. 12, 13, 14, 15 right there. 16, 17, 18, 19, and 20 right there. Excellent. All right. Hopefully I got that on camera. I don't know if I did or not. All right. Trial number 2, right? So right here, we're gonna fill in this column. So on 0 seconds, we should be at 0 meters. 5 seconds. Right over here. Went just past the 2. You wanna say 2.1 or 2.2? What do you think?
2.2.
2.2, we'll put for... All right, these should all be very close. Ideally, 10 seconds, which is the next mark. Looks like we've got maybe a 3, and then just before the 4, maybe a 3.9 or a 3.9 there. Okay, and then a 15 seconds is going to be our next mark. We've got a 5, and then I'll line you up kind of this way. I think a 5.8. I think a 5.8. Okay. Excellent.
This one's back in the middle.
Next one is the 4. Yeah, that looks just halfway. So you want to say 7.5?
Yep.
Excellent.
One more.
One more trial, and then we'll leave you alone. Look how close those numbers are as I wheel us back over. This time I will try to be a
They're
better
pretty accurate.
photographer.
I mean, we're really precise. Maybe not accurate, but precise for sure.
Precision is key. Reset.
Oh, my bad. It's my
All right. So once more, we'll turn on the car and start in 3, 2, 1, go. 2, 3, 4, and 5. 7. You want to persuade it? Yeah, there you go. 9 and 10 right there. 12, 13, 14, 15 right there. 16, 17, 18, 19, 20. Oh man, that car did not want to stay in line.
No.
All right, so going back, almost done here. It's gonna be about a 10-minute video for you guys this morning, or this afternoon, whenever you end up watching this. 0 meters, we're gonna mark first, okay? Go ahead and stop that. And at 5 seconds, notice we went past 1. We almost got to 2. I'd say we'll call it 2 though. I think it's close enough. Call it 2.0. Excellent. Okay, then we went to 3, 4, maybe a little bit past 4. 4.1? I think that's a 4.1. Yeah. 4.1 meters. And then 15 seconds is the next mark. We went past 5. We almost got to 6. I'll back it out so you guys can see. I think we're gonna make a judgment of 5.9. What do you think?
Yep.
Okay, 5.9. And then the last one at 20 seconds, we've got, it went past 7, okay, and it's just before the 8. I'd say 7.8.
Yep.
Yep.
That's what I was thinking.
7.8. Notice how nice those are. Okay, here's those numbers. Yes, we'll see you for the calculations video, guys. Good luck.